Okay, today we're going to go over how to convert a PDF to a DWG, and then we're going to review how to download equipment files from Fulton's website and import those into your own layout. While we do have a team here at Fulton that will happily handle all these drafting requests, this how-to video is just for those of you who like to be a little more hands-on or just need to skip the queue. Let's start off. We're just going to start a new template. So regular drawing file here. And then if you go over to the Insert ribbon, you'll see this PDF import button. We've downloaded a file from Fulton's website here, so we're going to go ahead and open that. You're going to see some of these options come up. You can review mine. It's pretty much standard import, and we're going to click OK. Put this anywhere on our drawing. When you import a PDF into DWG, it's not going to come in to scale. So what we want to do is we want to find one of the biggest dimensions on this drawing because that's going to give us the most accurate way to scale this. So here we're going to create a linear dimension. Now we're going to use our calculator. We can see that dimension is supposed to be 97 3/4. And we can divide that by 3.6188, giving us this 27 and change here. So now what we're going to do, we're going to scale this entire drawing. So we just type in scale once we have it all highlighted. And then we're going to use that 27 number to scale this to what we need it to be. So now if we go in and zoom in, we can see we're within 0.02 of what the scale needs to be, which is going to be perfectly okay for the purposes of doing a layout. So now you're going to see it actually imported a whole bunch of layers, even from this PDF. So we're going to turn off the ones we don't need because we're just trying to extract some of the geometry of the equipment and some of the clearances here. So we just flip these layers off that we don't need. Now what we want to do is create a block of this. So we're going to highlight all of the necessary geometry and then we're going to type in blocked. We can give this a name. This is an FBZ 1300. And then we're going to pick a point to right in the center of the boiler here, just to make it easier when we want to move around in your own layout. Perfect. So now we've created a block and we're ready to copy paste. We're going to use a Control-C, Control-V to paste this into our layout. We want to change this over into a layer specific to the equipment and make it easier to differentiate. And now we can move this around in our layout to figure out exactly where we want it to go. Next, we're going to talk about how we have the engineered systems ready and drawn on the Fulton website. So go to fulton.com, products, engineered systems, scroll down, click on drawings, then you can filter by 1 boiler systems or 2 boiler systems. Load them all. For this, we're going to grab a VMP 150. If you expand it out, you'll see we have a PDF, a DWG, and a Revit of that file. We've downloaded the DWG. We're going to do the same thing we just did. We're going to turn off the layers to what we don't want. We can then highlight what we want. We're going to create a block, same as before. And now we can copy and paste the entire system into your layout. And finally, let's talk about building your own system. So let's start with the boiler. We're going to do an FBZ 1300. So if you go to the Fulton website, we're going to go down to drawings, show all the results again. And when we scroll down to the 1300 and expand it out, see we have a PDF, a Revit, and a step file. So we don't have the DWG. So from the first part of this video, we showed how to convert that PDF to DWG. So we're going to use the same file. We don't have to go over it again. After the boiler, we need some of our ancillary equipment. So we're going to go to the ancillary equipment. Let's start off with our feed water system. So your feed water system needs to be greater than the combined horsepower of the boilers in the system. So for example, we're going to do a 2 FBZ 1300 system, which kilowatt to horsepower, roughly, we're going to say those are 130 horsepower boilers. So we're going to do 2 of them. We need 260 for a feed water system. So that's why we went with the HT300. Now we also want water treatment with the system. So how do we size water treatment? We're going to go to Fulton.com. We're going to look at the water softener guide spec or product data submittal here. When we open this up, we're going to scroll down to the chart. And we're at 260 horsepower for the total system here. So I'm going to highlight that row, and now we know how much makeup we have in the system. For this case, we're going to use 50% makeup, which tells us we need the FB900-910S. Now we go back to the website. We're going to look at drawings, and we're going to download the DWG for both the water softener and the chem feed. Now let's get our blowdown tank. Blowdown tank only needs to be sized to the horsepower of a single boiler because we only blow down one boiler at a time. So for this, we're not going to need an FC because we're not in Canada's jurisdiction. We're going to grab an F-150, and now we've downloaded that DWG. Now I'm going to pop this DWG open for the water softener, and I'm going to do the same thing we've already gone through. I'm going to make a block out of this. We're going to speed through here, and I'm going to paste that into what is going to be my new layout. So with a water softener, you also need a brine tank. So we can go to the next page of that product data submittal, look at our model, which is the 900-910S, go all the way over, and we have a brine tank of 18 by 40, 18-inch diameter. So we can simply add a circle to our drawing here. So circle, diameter, 18, there's your brine tank. And we want to keep that brine tank as close to the water softener as possible. And here we are, we're making blocks out of the chem feed. We're going to paste that in. Same thing with the blowdown. The blowdown, you want to remember this has going to have piping around it, so you want to leave a little extra space when you're laying this out. It's not showing the piping around it currently. And now we're doing the feed tank. Same as before, we're isolating the layers that we want. And we're going to drop that into our layout. Next, I want to show you the difference between our preheat and panel box orientations. So what I'm doing right now is I'm going to download an engineered system for a VMP and a VSRT. Once I have these open, you're going to see that the panel box and preheat are both on the left side for a VSRT. This is because the water column and blowdown are pointing to the right on a VSRT. But when we go and look at a VMP, this is going to flip because now our water column and blowdowns are pointed to the left on a VMP. So therefore, our preheat and panel box are going to be orientated to the right for a VMP system. And this depends on what boiler lineup you're going with. You can see this is just a view of our inventor assembly that we have the position set up to move this all around. You can see here, now we're flipped on the other side. And again, we can move this preheat in all directions that we need to. Whatever makes sense for the system. You'll see here in our quote template, we have all these set up ahead of time to make it easier for us. So if you get in here and you need to edit this feed tank to be better suited to what you're trying to do, you can see we can edit the block here. I'm going to rotate this panel box around. So I'm just going to rotate this, move it to where I want it. And then I'm going to mirror this preheat to flip to the other side. Now we could take this, move our equipment around. We want to keep the brine tank as close to the blowdown as possible. But yeah, now you can orientate it to your building how you need it to be. All right, that's it. Thanks for watching.